Checks. Control plane checks. In this module we will focus on how we can verify the control plane connectivity status. We will understand how to verify control plane connection status with the controller. Establishment of clear text and encrypted tunnels in the SD-WAN topology. Locally advertised and received routes. VRRP neighborship status in case of high availability CPE deployments. And LAN routing table on the respective LAN VRF. Controlled connection status. Control VR in AVOS appliance is a virtual router. It establishes a BGP connectivity with the controller for the respective tenant control VRs. We can view the BGP session of the VOS appliance using the command show BGP neighbor org name, brief. We can see that the appliance has established BGP neighborship with the controllers. In this case, there are two controllers. If for some reason the BGP neighborship is not established, you can check the detailed BGP session information in the CLI using the command show BGP neighbor org name, detail. Here we can find information related to the potential cause of the problem, like BGP finite state machine status, present in the last state. Last event. BGP notification messages give these details. Send and receive errors. We are not going to get in greater details into troubleshooting BGP. The next check is to verify if the branch has the SLAs up with the controllers, and with the other branches if applicable as per the topology. We can view the SLA status by using the CLI command, show org tenant name SD-WAN SLA monitor status. This will show the SLA status on all available transport links with the controllers, and the other branches. In this section we will understand how to view and verify the clear text and secure tunnels that are established from a branch perspective. To view the dynamic tunnel interfaces, use the CLI command, show interfaces dynamic tunnels. This will show the dynamic tunnel virtual interfaces, DTVI, and the corresponding TVI interface used for encapsulation of the traffic to the remote site, either branch or controller. The branch at first establishes these tunnels with the controllers which are present in the SD-WAN network, and establish the tunnels with the other branches depending on the SD-WAN overlay topology that has been defined. In this case, we have a hub and spoke topology, with spoke-to-spoke direct communication. So we see that the branch forms tunnels with the hubs, and the other spoke sites as well. In this section, we will understand how to see and verify the locally advertised routes into the MPBGP. To view the locally advertised routes into MPBGP, use the CLI command. Show route table L3 VPN IPv4 unicast routing instance tenant control VR instance advertising protocol BGP. This shows the routes advertised into the control VR. The peer address is the controller IP. We can imagine that as a route reflector. The MPBGP route has the following attributes. A route distinguisher, prepended to a prefix to make it unique. VPN label, used for demultiplexing the traffic and sending it to the right interface. And extended community, used to define VPN membership. To view the received routes, use the CLI command, show route table L3 VPN IPv4 unicast routing instance tenant control VR instance receive protocol BGP. We notice that the peer address is that of the controller, and the next hop IP is the management address of the branch, which is advertising the route. In our case, we have two hubs and two spokes, in a hub and spoke topology with spoke-to-spoke communication. So, when we look at the received routes for the segment 10.10.30.0/24, which is the LAN segment of spoke 1, we see that it is received directly from the branch with a local preference of 110. And via the hubs, with a local preference of 102 when received via hub 1, and a local preference of 101 when received via hub 2. So the route with a local preference of 110 is the best route and is installed in the routing table with the other two being fallback routes. This also explains how the spoke-to-spoke direct communication works in Versa SD-WAN. Verifying LAN routing instance. In this section, we will understand how to view the LAN routing instance, and how to identify the SD-WAN routes. To view the LAN routing instance or the LAN VR, use the CLI command, show route routing instance tenant name -LAN VR. This will list out all the LAN routes along with the next hop. All the routes received via SD-WAN will be learned via BGP, and the next hop will be the management IP address of the remote branch. In this case, we see that there are more than one route for each remote LAN segment. It is because we have a hub and spoke topology, with 2 hubs, and spoke-to-spoke direct communication enabled. The active or the best route is prepended with a plus sign. VRRP checks. In this section, we will understand how to verify the VRRP status in a high availability deployment. The Show VRRP Group Summary command shows the VRRP status. VRRP uses multicast. In case of communication issues, both appliances will be in master status. Troubleshooting involves unicast and multicast reachability. Other aspects like MAC address learning and VLAN problems if used should be checked in case of VRRP issues.